All right, this is geometry, lesson 4-3, proving triangle similarity. Lots of proofs today. Today's date is Thursday, February 4th, 2021. Objective. Oh, Emma, go.
Construct proofs that triangles are similar and find student errors in those proofs.
Yeah, and then for that second half of our objective, I don't really have examples. They're more for the homework, so you're not going to get a good idea of the types of errors that students make. I'll try to mention them along the way. Let's go ahead and mention our similarity criterion. We talked about them in 4-2. Give me one of them, Kira.
Angle, angle.
Angle, angle. That's the new one. That's kind of the big one. What's another one, Charles?
SSS.
Side, side, side. That was in the last lesson. Yeah. What?
Side, angle, side.
Side, angle, side. And that's kind of all you need, but let's mention all the other ones.
I'm going to say angle, side, angle, right?
Yep, angle, side, angle. And there's one additional one if you want it. Ulysses?
Is it side angle?
Yeah, side angle, angle. The one thing I'll say about these two, which I should have said last time, is look, there's two angles. You don't have to do those, just go angle, angle theorem. So that's a quicker way of doing it. But they still are valid criterion. It's just there's a faster way. All right, so these are typically going to be the reasons that you'll see on Khan Academy of the right-hand side, what you're going to be looking for. Anything that's not in this list, either I messed up and forgot to put it in this list, or it shouldn't pop up on the homework, or quiz, or test. All right, so I'm drawing pictures for each of these. Vertical angles are congruent. What picture would you write? Can you do it with your arms? You could probably do it with your arms.
Well,
Question?
like, what do you mean by vertical angle?
Yeah, that's a good question. So if you don't know what vertical angles are, this is where the picture is going to help you. If I was doing it with my arms, I'd be like, boom.
Oh yeah,
boom.
that makes sense.
This is the picture that I draw for vertical angles. Just two lines, and I'd say those two are equal to each other.
Oh, that's right.
Or if I wanted to do a different color, I could say those two are equal to each other. Those are vertical angles. And vertical angles are congruent. Again, if you don't like this word congruent, you can cross it out and think of the word equal to. Those are equal angles. The measures are equal. All right, alternate interior angles are congruent. What would you draw in the air?
Wait.
Ah, that's even better, yeah. Question?
Yep. So what is not a vertical angle if both of those are vertical angles?
If I had two lines, this angle and this angle are not vertical angles.
Oh, so it's just if they're across from each other.
Exactly, they have to be across from each other. Yes. Most people are doing the Zorro, or you're doing some sort of trying to do alternate interior that way. That is perfect. You know what you're doing. You have a pair of parallel lines, chunk, 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 chunk. Those are parallel, crossed by a transversal, and it's the armpits. Armpit, armpit. That's vertical angles. Maybe that diagram is too complex. Maybe I'll just assume that you know that these are parallel lines, and then draw a transversal, and then draw the armpits. Armpit, armpit. That's alternate interior. That's your picture that you need to know. Corresponding is again very similar. I'll draw the same parallel lines, parallel, parallel, transversal. But it's not inside armpits. It's, yeah, Charles has it down. How would you do it? You have that angle and you just move it somewhere else. So if you have,
So it,
yes.
so it could be the inside armpits though.
No, so this, it's not rotated or anything, it's simply translated. So if I translate it down here, then those two are corresponding. I can't have this because that's kind of like twisting it around. I'm just simply translating it down along the transversal.
Right, but like say for example the top angle that could be considered an armpit.
Can you point?
Like this angle could be considered an inside armpit angle, right?
This whole thing?
Just yeah, that angle. Because when we do this one, like this. Is
Okay, yes, it's one inside armpit, but you can't do both armpits.
Okay.
Yeah, exactly. I see what you mean. Yep. Any questions so far? And then the easiest of all of them is called the reflexive property now. They're actually using the correct term finally in Khan Academy. And I don't know, how would you describe it with hand gestures? I'd have this and this, like they're the same thing. Like, I don't know how you do that. Or you can have maybe the equal to symbol with your hands. Here's the way that I'll say it, like, look at this angle. It's the same angle. It's the same. If you're just referring to the same thing over and over again, it's called the reflexive property. It's like saying, hey, look, angle A is angle A. Did you know that? That's crazy. It's mind-blowing. It's the easiest one to use, but just know it's called the reflexive property now. All right. Prove that triangle LMN is similar. Again, that symbol, this little tilde down here means similar to triangle OPN. So what is it talking about? Prove that that triangle over there and that triangle right there are similar to each other. That is the proof. This proof can be done in 4 to 5 lines if you're doing it right. Charles?
Well, I think I have an answer.
Oh, you already have the entire proof? Oh my God. Well, give us the first step.
L and M is parallel to P and O.
We do need to have that. And what is the reasoning for that?
Given.
Yep. So we have, again, statement, and then our reason. And hey, these are all the list of the reasons that are kind of going to be used today. I guess I should have given in there, but that's too easy. You guys know givens. So the reason here for Charles is it's given, and we have LM, that line segment, is parallel to PO. And let me make the rest of our column for our 2-column proof. Good enough for me. All right. And that's really the only given that you have. I mean, you could say L is equal to 5, or Ln is equal to 5, Pn is equal to 8, but that's not going to help us yet. Ooh, lots and lots of hands. Let's give it to Emma.
Could we do like LO to NP, and that would be given? Or what?
LO to MP. What about that?
Like it's what? Like that would be another given, right?
What about them? Are you talking about that they cross each other, or?
Yeah, that cross.
They do cross each other, but you don't have to say that given because it's demonstrated by the diagram. When there's little marks like that, you do want to kind of point those out, but the fact that they cross each other is just from the diagram. But yeah, good. That crossing each other is kind of the next step. What about crossing each other can we say next? And I'm not going to put the pressure on you, but any other steps? Let's give it to Kira.
L to angle L and M is equal to angle P and O because they are vertical angles are congruent.
Yep, vertical angles are congruent. I like that you said the full reason, so I'll write that down. Angle, or I should say, did you say congruent or did you use equal? Are you talking about the measures or just the angles?
Well, I don't know. Well, they're the same, like size.
Okay.
Makes sense?
We'll use the congruent one. So we'll say angle LNM is congruent. I'm not using equal to because I'm not talking about the measure. If I had measure, then I'd use equal to. So I'm just saying congruent to angle P and O. P and O. And it doesn't matter the order in which you write these because you're just talking about N and N again. And again, we'll write I should type this because it'll be neater for the notes. Size 14-ish. That sounds about good. Vertical angles are congruent. Congruent. I can spell. All right. No questions on that. I don't see any cues. All right. Looks like we're on Wyatt now.
Yeah, I think I found another angle.
Ooh, okay. Yeah, what do you got?
So I think angle NLM is equal to angle NOP because of alternate interior angles are congruent.
There it is. So say angle NLM is congruent to NOP. Angle NOP. Nope. Yeah, exactly. And I'll type in here, alternate interior angles are congruent. Oh, nice, it actually detected the picture and tried to move it around. That's pretty cool. Good job, software, but I do want you to run into it. Yeah, and I mean, you guys can hopefully see this. You can see that if I extended that parallel line, that, and then I have the transversal armpit, those are the inside armpit, that is alternate interior angles. And we have one final line in our proof. Jade?
LMN is
Not equal to. It's similar to, yeah. Oh, you're doing the other angle. Yes. Yeah, that works. Okay, sorry. I misunderstood you. So we're saying angle, so it's this one and this one, right? Angle LMN is congruent to, oh, that's a bad tilde, is congruent to angle NPO. NPO. And okay, so this is something that you're allowed to do in your proofs if you ever see it in my class. Same reason as above. Just quote, which means the same thing as above. All right, we do need a final conclusion. Who has not? Have I called on you yet, Charles, today?
Yeah.
Okay. Has there been anyone that I haven't called on yet?
Oh, can I hold it up?
Yeah, go for it.
Dave over here.
Yeah, Dave.
If you know it's the final line, you know I'm going to be using one of these three. That's going to be the reason. Asha?
Okay, so triangle LMN is similar to triangle LPN because I'm pretty sure it's gonna be side angle side.
Side, angle, side. Not quite right. Because if I analyze all of these statements to put an angle or side with them, this didn't give us anything, but it did give us the fact that we're allowed to use this one and this one. So we have, this one is an angle.
So then you could do angle.
This one was an angle. This one was an angle. And you're right, we could use angle. We could do, get rid of that S. I just wanted to delete it. Go away. Okay.
Yeah, would you?
Question, go for it.
Would you get it wrong in Khan Academy if you put angle?
It'll be a drop down, so it won't even be an option.
Oh, okay. But like if you were like.
If you were in this class, I would prefer you to only say angle, because that's the technical theorem that all mathematicians would see.
Okay.
What? Yeah.
The reason why angle is kind of better is because it's just shorter. If two angles in a triangle are congruent, then the last angle must be the same as well, because all angles in a triangle add up to 180 degrees. So it'd just be angle. It's kind of like a short version.
Yep. Again, we didn't really need this line, but it's always nice to have extra information. It shows that you know what's going on with this diagram. Perfect. And I should have steps on here. Eventually, once I do substitution and stuff like that, I'll probably put those back. All right, we're done. Put our little black box.
Wait.
Question, go.
Yeah. So how do you decide the criterion? Because it's like, do you just look at the last few steps?
I'm looking at what we have over here. What is in our arsenal? We proved one of the angles are congruent. We proved another. Therefore, we can say angle. If I somehow prove that the sides are proportional, I put an S over here, then I have one S in our arsenal, and I might be able to go with a side. If I have all three of them, or if I only have two of them, I'm probably going to be going with this theorem. It's just depending on how many of these angles or sides I've been proving.
But like, the top proof was of a side, right?
There are no sides here. This was just parallel lines. There's no side is proportional to a side. You'll see in the next one proportionality, so you can distinguish between the two. I think that'll help. Because in the next one, it's going to be I'll give it away. It's going to be side, angle, side. And it's very, very clear that it's, we're proving a side over here, not an angle.
Okay.
You ready to go for the next one already, Wyatt?
Yep, I'm ready for that.
I see it.
Easy given.
Oh, man. I'm actually curious what your given is going to be. Let's go ahead and make our two columns. I want to make neater lines.
I see one given.
Line there, line there. This is going to be our statement and our rationale, our reason. Why can we say this statement? What about this diagram do we have? Wyatt, what is our given?
Our given is that line segment WU is congruent to line segment UT.
WU
and then UT
is congruent to UT. Okay?
6.
Yep.
The line.
Charles?
Angle WUB is congruent to SUT.
Good. And was it a question, Jade, or an answer?
It's a question.
Okay,
So
yeah.
because WU is congruent to UT, would that mean VU is congruent to US?
No, and you can see they're not, like 4 and 9, so they're definitely not congruent.
Oh, because
Yeah, they're just going off of the lengths.
That's okay.
Question? Or are you giving an answer?
I have an answer when you're
Okay, yeah, let me write down Charles' thing. So Charles is saying those two angles are congruent. Did you say the reason yet?
Vertical angles.
Vertical angles, perfectly. All right, vertical angles are congruent. So we'll say angle WUV is congruent to angle SUT. SUTY, and then I can just grab you. This is why I typed you. I can just paste you. Aha! Vertical angles are congruent.
Then it would be Wyatt's name.
That would be cool. I said J. Is it James for middle name? What did you say?
Close.
No. Me?
Yeah.
No.
What's your middle name?
Joseph.
Joseph. Okay. All right. So far, so good in our proof. We're chugging along. Question, yeah.
Well, I was gonna give you an answer.
Okay, go for it.
WV equals, or not equals, but like, focus on.
Parallel or
Yeah, WV is parallel to WU.
WU? Oh, these two lines aren't quite parallel to each other, though. Yeah, parallel just means that they're the same distance, always, never intersect each other. So this next step is really hard because you haven't seen it before. Oh, yeah, Kira.
Well, I think I found a proof. Like angle WVU, where like V is the point, would be equivalent to measure of angle UTS because the corresponding angles are congruent.
These two bottom ones?
Yes.
Not quite. So so you're only allowed to use that theorem when you have parallel lines. Until you have parallel lines, you don't have permission to use it. And we don't actually have parallel lines, so we won't be using that. But a good attempt, yeah. If we had those, then angle, and then we're done, right? So this one you haven't seen before. We need to somehow use sides. I told you guys my hint. I'll even write down our final line down here. This is what our final... Oh, I didn't mean to do that. Go away. Our final line is going to look like this. This is the statement. And then our rationale will be side, angle, side. Side, angle, side. And then I won't write the box because we're not done yet. This is going to be a therefore. That's our final line. But we have an angle here. I'll write down our angle. This angle is this angle right here. But we don't have any sides. And again, with similarity, you don't say sides are congruent. If they are, then that's awesome, because I guess you could say that is a side that is congruent. But the problem with that is the other pair, 4 and 9, aren't congruent, so we're going to have to use proportionality, not congruency. Yes?
Don't we have the side already? The 6 and 6?
Yes, that's kind of what I was just saying right now. Like, this is a side that Wyatt mentioned at the very beginning. So we have a side and angle, but now we're kind of stuck. So this is the new step. And I'm going to undo all of those because it's not really a side that we're going to be using. Because you can see, you want to compare like the largest to the medium. So large to large and medium to medium. So those are the two that are going to be paired up. So this is how you're going to say it. You're going to say that the ratio of WU, that's the long one, to the other long one, to SU. Again, I'm looking at long WU, which is the longest of the two, between 6 and 4, 6 is bigger, over SU, and SU, 9 is bigger than 6, so I'm doing big over big. This proportion, and how do I color code this? I don't know. This proportion is equal to this other one. So I need to do, again, the smaller triangle piece, so it's going to be VU over TU. These proportions are equal to each other.
Yeah.
And sometimes in your proof, you can do stuff like this. I think Khan Academy does it this way, so maybe I'll copy them. Because we're basically done after this, so I can move down here. Sometimes you can do this. You can say WU to SU is equal to 6 over 9, which is equal to... what does that reduce to? 2 over 3. And then you could also say, I ran out of room there. I see the question, hold on. VU over TU is also equal to 4 over 6, which reduces to 2 over 3. And then after you do this and this, then you can set them equal to each other. That's kind of how Khan Academy does it. I'm okay with you jumping right down there and just saying substitution. I know that having it this way does make it a little bit clearer. Now question, yes?
So for like WU over SU, is the proportions are equal, would just that one statement equals 2 sides?
Yes, exactly. This statement right here, this gives you a yellow side and it gives you a green side.
Okay.
In fact, when you set up this similarity proof and you do side, 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 all 3 sides are in one line. All of your sides will always be in one line because you need to compare all the proportions at the same time. If you forget one of the proportions, like they're all 2/3, except for that one, he's like 7/9, but whatever, we don't care about it. No, they all have to be the same. And we are saying that they're the same. You can say that they're equal to 2/3 here. So the rationale that is typically given is substitution. And I know I kind of went out of order, but let's kind of go back to Khan Academy. If I said that this was step 1, step 2, step 3, step 4, step 5, and step 6, then I say substitution of 3 and 4. Because I'm using the fact that 3 was 2/3, 4 was 2/3, they're both 2/3. And now we're done. By side angle side, now I can draw my little black box. We have finished our proof. Let me go over this one more time. I should also mention that we didn't really need this line. It's good to put in your proof, but again, the way that you always make your proofs look nice and professional is you get rid of everything you didn't really need. All right, what do we start with? We start with the obvious angle by vertical angles. Everyone has seen this many, many times before in our last unit. We're here. The hard part is now saying, all right, let's check the proportions. Again, big to small, big to small. Are those equal to each other? Well, I did big to small. I checked, yes. Big to small, 2/3. Check the other one. Medium to medium, I guess. Hey, that's 4/6. That's still 2/3. Now that they're both the same, we'll conclude, yes, the proportions are equal to each other. One of these is a side. This yellow, orange one, whatever, is a side. This green one is a side. I got 2 sides from this piece of the proof. Now I can do side, angle, side, because I have side, angle, side. The angle is in between the sides. That does make sense for side, angle, side. Question mark.
So you're allowed to say that they're similar because of the fraction.
We're similar because the sides are proportional. If the sides were congruent, then we could conclude that they're congruent triangles, yes.
Is this kind of related to like SOHCAHTOA or no?
No, not yet. No, we haven't hit trig yet. It's coming in the distant future. I still have to talk about normal right triangle Pythagorean theorem stuff first. All right. Questions on example 2, Jade?
This is a comment.
Comment, yeah.
Aren't we doing trig in algebra 2 right now?
Yes. Your introduction to trig is in geometry, though.
So we're doing trig before we learn trig.
Well, you guys are dual enrolled, so you have to take it with a grain of salt. There's a few overlaps like that.
Roll with the punches.
Exactly. Yeah. I thought of a few speed sheets that we can do for geometry, just so that you guys can hate me a little bit more. It'll make my life more enjoyable.
I don't want to hate you, Mr.
I'm always joking. Like, speed sheets are a really good tool to make sure you have the basics memorized. All right, example 3. This is a thing that happens on Khan Academy. I thought I'd give you the hardest type of problem possible, just so you're really prepared. There are 3 triangles there. You might only see 2, but there are 3. There's the overall really big one, ABC. That's this ABC, that really big one. And then there's that medium-sized triangle, BDC, or BCD, this medium one over there. And there's that really tiny one over there. Those 3 triangles are all similar to each other. You can't prove it because I haven't given you enough stuff to prove it. But I'm just telling you, they are. I constructed it that way. So you know that they're similar to each other. If they are similar to each other, then what are the corresponding sides? You have to match them. And on Khan Academy, it's more electronic and awesome. You get to drag this box and you can click down and drag it so that they're all in the right line. But for this basic version, I'm just going to draw a line and say AB, and that's CD. Those 2 go together. Find corresponding sides. And this one is hard because you have to like rotate them in your mind. You have to say, okay, which one is the big one? Which one is the small one? Which one is the medium one? So let's start easy. Instead of connecting them right away, let's just identify in this big triangle, what's the big, what's the small, what's the medium? And I'm going to write big, small, medium. Charles.
Big side, I think, would be AC.
AC is the big side. Big.
CA.
Or CA. It doesn't matter. Yeah, we're good. Okay, someone else give me the small. Of this really big triangle, which one is the small? Emma.
A and D.
A and what?
A and D.
Oh, A and D is a piece of it. I'm talking about this entire triangle, though. So those, the only three lengths you have are that length, and that length. Which one is the smallest? AB. There it is. This one is small, and therefore I can do the medium. It's the one that we haven't labeled. This one's the medium. This is how I think about it, too. I have to compare big, medium, small. All right. Now we're looking at the right-hand side triangle, this medium-ish triangle, BCD. Which one's big? Which one's small? Which one's medium? Ugo.
BC.
BC is the...
Big one.
It is. Isn't that weird? BC is the same thing as BC, a big and a medium. They're different ones. That's why it's confusing. All right. Someone else give me another one. Hazi.
DB is the small one.
DB is a small one. There you go. And I'll do the hard one. That's the medium. All right. All right. Final triangle. This triangle on the left. Kira.
BD is the medium one.
BD is the medium one. I agree. Ulysses.
AB is the big one.
AB is the big one. And I'll do the hard one. This one is a small one. Isn't this cool, though? Look at this. AB over here is small. AB over here is big. That's why this type of problem is confusing.
That is confusing.
And I'm going to put one of these on the test where they're having numbers and you have to do some solving. And I think they come up on Khan Academy too. It gets hard here quick. The proofs are hard in their own way. So what do we match? Well, small goes with small. So this goes down here and that goes down here. All right. Medium goes with medium. Boom, boom, boom. And
Whoa,
big goes with
hard.
big. That's how I draw out my lines.
So on Khan Academy, you have to. What is
You'll
it?
drag them around instead of drawing lines.
Oh.
Yeah, so just be ready. Usually they just do 2 columns. They don't have 3 triangles. I did as hard as possible so you won't see this level on Khan Academy. All right, and the hardest... Oh, question?
How would you answer this?
Oh, you just drag them around and hit submit. You'll make sure that AB is in the same line with DB.
Oh.
This I would drag DB to the very top.
Oh, okay, that makes
I
sense.
see.
All right.
And then you would drag
CD to the very bottom.
CA to the top as well.
Oh, yeah, actually, yeah. That would be like
You drag CA to the top if you want to make it.
AB, you could drag to the bottom to make them all small, 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 small.
And then big, 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 and then medium.
Actually, you're only allowed to drag in this column. You're not allowed to drag in that column, I think. So whatever. You'll figure it out. It's not too hard. If you understand this, then you'll understand Khan Academy. This was way harder than Khan Academy. Example 4. This is the hardest proof that I saw on Khan Academy. It uses a reflexive property, which we haven't used yet in our proofs today. Question, Emma.
Well, I think this would probably be a common, but
Okay.
RJ and is congruent to FG.
You are correct. Yeah, I can write it down.
And that's a given.
Are given here. We have a length of 2, a length of 2. So indeed, IJ is congruent to FG. Perfect. Great way to start it off. Strong given. This is our reason. And we need our statement. And I'm going to start labeling these. We might need that later. Yes. Asher.
The other given I think is angle FHJ is 90 degrees.
Yeah, let's do it.
We got an angle.
I should say the measure, I can't write my M, a measure of angle FHJ is equal to 90. Perfect. I think that's all of the givens that we can have for now. Darn, there's no parallel lines. We can't use alternate interior. We can't use corresponding. That limits your choices quite a bit. I will go ahead and do the last line for not the reason though. You'll have to figure out the reason. Our last line is that though. Those 2 triangles are similar. I'll do the little therefore for you as well. Boink, boink, boink. Therefore, those 2 triangles are similar. Let's go with Kira.
Well, I think angles like I guess just angles F and J are equivalent.
You're right, they are, but you can't prove that yet.
Oh.
Are you just eyeballing it, or how'd you get that? Yeah, they are. You're actually correct. If once we prove that they're similar, then since corresponding parts of similar triangles, I guess I have to say corresponding angles of similar triangles are congruent. You would be correct by that, but you can't do that until after we're done. You could say that like on this line down here. Yeah, what?
I think that you can say line GI is parallel to FJ.
Again, yes, but you'll say that down here.
Uh,
And you'll say it after her line, actually, because you'll have to first get the angles that she talked about, and then you can say that they're parallel. Sorry, can't say that because it's not given to us. You can only do that once you have angles, and we have only one angle. Let's go. Emma, question?
Did you say IJF is the same angle as GFJ?
Yeah, and that's kind of what Kira was trying to say, too. Aren't those the same angles? And they are. Again, we can't say that until we prove that they're similar, though. Yeah, it's good that you saw that. Let's go Esha, and then Charles.
Well, I think could we do GH over HI is proportional, right? That's how you say it?
GH over HI. Yeah,
Like,
let's do it that way.
I'm trying to do something with 6 and 4, and I want to know if that's right.
That's fine, yeah. So we'll say GH over HI is equal to 6 over 4, which reduces Esha to
3 over 2.
3 over 2. Good. And you can just say math.
Okay.
Did you know that 6/4 is 3 halves? I did. It's by math. You can say reducing if you want to be more specific in the type of math, but that's fine. Yeah, just say math. All right, that was a good step 3. And you do need that because once we set that equal to something else, we might be able to say something. Charles?
FH over HJ or JH is 8 over 6.
Which is?
3 over 2.
3 over 2. Whoa, whoa! That looks similar. Whoa! And I'll say math.
Wait, wouldn't it be 4 over 2?
Wouldn't it be 4 over 2?
Yeah.
Because it's
Oh.
8 over 6.
Oh yeah, you're right. Wait,
it'd be 4 over 3. Be 4/3.
Yeah, it'd be 4/3.
Right, 4/3.
Oh, yeah. Darn it!
Mr. Sindel, was that supposed to happen?
Yeah, it's because we were not doing our proof right.
We're not
Question,
doing it right.
Emma. It's okay. I'll show you guys why.
If I was comparing HDI to GHI, would that still be like me comparing GF, like the same angles?
Yeah, so we're going to kind of ignore the angles. We're going to focus on sides now because we can't do anything with angles until we have similarity or congruence. Yeah. All right, so who did step through? Is that Esha?
Yeah.
Yeah, so we compared two things that weren't really the same. We want to compare corresponding sides. So we want to compare this length with this length.
Oh.
That's what is causing our error.
Wait, you want to compare
The blue with the
FH
orange.
with FH?
Well,
FH to GH.
Oh.
okay.
Yeah, because those two, it might have worked. I thought it might have worked, but it didn't. So we'll do corresponding. So let's come back up here. Sorry if you're taking notes. I have technology. Lo siento. So we'll say GH to FH. FH is, I don't know. Someone else help me. It's something.
Huh.
Jade?
6 over 8.
6 over 8. There it is, yeah. And that's the confusing step. I know that I said I would talk about common mistakes. A lot of people will mistakenly think that this is 6 over 2 or something weird like that. You do have to add 2 and 6 to get the entire length of FH. That's one or two of the mistakes that people make on Khan Academy, the fictional students that they have. And Jade, help us out. 6/8 reduces to 3/4. Yay! All right. Let's compare the next one. So
Oh.
it's still math, yeah. And then we're going to do that one to this one. Who's got the next one? The reason is still going to be math. The statement now, Esha, is going to be...
HI. Oh, wait.
Yep, HI.
I got HI over HJ equals 4 over 6.
There it is. And what is going on?
Which is not equal to
Whoa, this is not similar, Mr. Sindel.
They're not similar then.
We did it. We finally proved that it's not similar.
I thought I chose one that was similar. Am I making a mistake? Because that's why I had a feeling that the other one should have worked as well.
So in Khan Academy there, so
Did I make that big of a mistake? Wow, I'm sorry, guys. I thought I chose one that's similar. Well, we have now proven that it is not similar because there's not enough information. So you can say the side here is not, I guess, what do we want to say? Therefore, they're not similar. This is going to be step 5 down here. And then our general rationale is the sides are not proportional. I feel very silly up here. I thought that they were similar. They're not, and we've proven it. Esha first.
so on Khan Academy are there questions that are not going to be similar?
Yeah, there will. Half of them are not similar.
Okay.
Yeah, Charles.
So what if the way that we did before would have worked, like the FH over HJ?
That would have worked. Yeah, that should have worked. Because you're still comparing. Because the way that proportions work, they're kind of fun. You can either say, you can compare a big triangle to a small triangle and set up your proportions so that your proportion is big over small is equal to big over small. Or you can just compare sides. You can do, say, big side here and small side as your category, and then you can do the big triangle over the tiny triangle is equal to the big triangle over the tiny triangle. Both of these proportions will work, no matter what your category is. Esh's first category, and I'm sorry for saying that you're wrong, that would have worked, and I'm feeling super guilty because I told someone incorrect. That would have worked because you're comparing two different triangles. Your category was right here, which didn't work, and then what we just did was we compared sides, which also didn't work. Either way will work. Yeah, what?
So let's just say if step number 4 was equal to 3/4, then we could have said something like side angle side for equal or something.
Yes, but we would have had to have an additional step, and I'm glad that you talked about it because I wanted to use the reflexive property. We would have had to say something for step 4.5. Has to be in here, right? That angle H is congruent to angle H by reflexive.
Woo!
And therefore, that is our final angle. So we have an angle. This would have been a side. This would have been a side. And then we would have had something like side angle side. But it's... Did I spell reflexive with an F? Oh my God, Mr. Sindel.
It's just an off day.
Yeah, we'll say that. Question, Kira?
Can you do side angle?
Never. Unless you're using hypotenuse leg for congruency, but never. Because that's ASS. That's a bad word. But generally speaking, it doesn't work because it could be two different types of triangles. I'll give a general picture for angle side side. Angle side side or side side angle if you prefer. I like this one because it's a bad word. Or it's a donkey. I don't know. You could have a triangle like if this length and this length are the same and then this length is here. We know that we'll say that side, side.
And then
Oh no, sorry. I'm gonna say side, side, and this angle are the same. Watch, I'm gonna copy this exact same thing and watch this magicalness that's gonna happen here. Boom, boom. I can grab that
The angle.
and get the same exact length. I don't know why the what? Why? I did it correctly, computer. You're just being silly. Is it because it doesn't like reverting it backwards? Oh, got it. Okay. Ah! Okay, I'm just gonna redraw it.
It doesn't.
When technology doesn't work. But anyway, that's still the same length, and this is still the same angle. But notice that these are very, very different triangles now. That's why angle side side doesn't work. Because this yellow line can be flipped in or out.
You broke it, Mr. Sindel.
There's two options with angle side
You
side.
broke the donkey.
I know. I broke it.
You broke
Turn
the
it into a
donkey.
mule. All right, so that is our lesson. Sorry about example number 4 not working out. I think you get the general idea here. I assume that our objective is going to have a lower fist of 5. Let's check. Fist of 5, construct proofs for triangles and find maybe student errors on Khan Academy. How well are you feeling? 4, 4, 3, 3, 4.5, 3.5, 3-ish, 4, 3. I'm sure was that a 3.5?
I
Okay.
my fingers can't bend the way that I want them to. This is